So we'll get started. Where are those two? Okay. So listen. Shall we get started? Only three. Where are others? Okay. Okay. So listen to this question. Okay. Listen. The plot of the variation of potential difference across a combination of three identical cells in series versus current is shown in the figure. What is the EMF of the cell? So if you read the question carefully, they have given a graph which shows a variation of what is there here, which shows the variation of potential difference and current. Okay. And there are three identical cells which are connected in series. Okay. Now, if you observe, the EMF here is E, here also it is E, and here also it is E. This is R, R, and R. Right? So if the three cells are connected in such a way that the positive terminal of the first is connected to the negative of the second, right? If this is how the sequence is connected, what is going to be the equivalent EMF in this case? The equivalent EMF will be, yes. So it is going to be 3E, right? These cells will get combined to give you a battery, right? And what is going to be the resistance value? R plus R plus R. It is going to be 3R because they are in series, right? And let the current be I. Okay. Now, what is the relation between the terminal potential difference and EMF in this case? So when the battery is getting discharged, what is the relation between terminal potential difference and the EMF? Just check your notes and tell me. So you hold it for today, right? You will be able to speak. V is equal to, sorry, yes, V is equal to E minus I into R. Okay. So here in this case, what will I write? V is equal to, what is the value of E? It will be 3E minus I is I only into R is 3R. Am I right? So V is equal to, in the place of E, I will write it as 3E because the cell's EMF is 3E. And what is the resistance here? It is 3R. Right? So when I write the equation for this line, what will I get? Observe, this point is 0, 6 and this point is 1, 0. What shape does it take? It takes the shape of a straight line. So for a straight line, how do you find the slope here? So y2 minus y1 divided by x2 minus x1. So if you see the slope here, the slope of the line is minus 6. 6 minus 0 by 0 minus 1. It is minus 6. Right? What is going to be the equation of this line? Y minus y1 is equal to m into x minus x1. So I'll use the equation y minus y1 is equal to m into x minus x1. Am I right? So when I use this, what is the value of y here? Y is v. So v minus, what is the value of y1? You can take either of the points. If you take 1, 0, then y1 will be 0. If you take 0, 6, y1 will be 6. Which one you want to take? 6, huh? Okay. V minus 6 is equal to ms minus 6 into x is how much? X is I. Okay. I minus, because you took y1 as 6, x1 should be taken as 0. Right. So v minus 6 is equal to minus 6i, which implies v is equal to 6 minus 6i. Am I right? Now tell me one thing. This is the equation framed according to physics. And this is the equation framed using mathematics. But if you see the LHS for both the same, if that is the case, I can compare the RHS. When I do that, I get 3E minus I into 3R is equal to 6 minus 6 into I. So 3E is how much? So E is how much? 2. Similarly, 3R is how much? 6. R is equal to 2 ohm. Suppose the question was based on what is the internal resistance of each cell, the answer will be 2. If they ask you finding what is the EMF of each cell, the answer will be 2 volt. Okay. Did you understand this? Right. Now the question is, can we solve this problem faster? Right. Let me say I don't get this idea, but I want to solve this problem faster. Then what you can do is, if you look at the alternate way here, then observe. What do we mean by 0 here? 0 is current is 0. So when the current is 0, what is the corresponding potential that is coming out? It is 6. So what is the basic definition of EMF? EMF is the potential difference across the terminals of a cell when the current flowing through it is 0. So to put it simple, can I say that 6 is the EMF? Right. 6 is the EMF, but the question is, what kind of EMF is it? It is effective EMF. Why effective? Because there are 3 cells that are connected in series. Clear? So when that is the scenario, when 6 is going to be the effective EMF, 6 is equal to, when 3 cells are connected in series, what is going to be the net EMF? 3E. So what is going to be the value of E? So this is how you solve the problem faster. I hope you are able to relate both. The reason why I did this is, suppose in the exam, it twist and out is the, instead of EMF, they ask you to find the internal resistance. You should be in a position to do it. Right? So this is the solution. Make a note of. Write it down. Where do people live? Right? Shall we proceed? It's a very big problem. It take time. Yeah? Just go through the video. See, simple. I this point I can explain. There is a graph that is showing the variation of potential difference in current. Okay? So what is happening is there is a combination of three identical cells. So three identical cells, they are going to look like this: E, and R, and R, internal resistance. Okay. If I replace them with equivalent resistance, it is going to be 3E and 3R. I hope this point is clear. Now the question is, what is the EMF of each cell? It is not the combination. What is the EMF of each cell? Okay. So what I did is I wrote the formula V is equal to E minus AR because the cell is getting discharged here. So when I wrote this, E is, so instead of E, I replaced with 3. Instead of R, I wrote with 3R. That is first equation. Second is, with the help of this graph, I wrote the equation using mathematics. Y minus Y1 is equal to M into X minus X1. I found the slope 6 minus 0 by 0 minus 1, which is minus 6. Then I wrote the equation. I got V is equal to 6 minus 6i, which is the second equation. So first equation and second equation both get corresponded to the same potential difference. So I compared the right hand side. When you do that, 3E will come out to be 6 and 2R will be coming out to be 6. So using that, I found the value of EMF of each cell and internal resistance of each cell. Okay. But what I told is there an alternative to solve the problem faster? Because here the question is only about EMF. So I taught this because if they ask about internal resistance, you should know how to handle it. Right. So if they ask only for EMF, what you can do is look at the graph. Just go with the definition of EMF. What is the EMF? Potential difference in open condition. Open condition means I is 0. So when I is 0, x-axis is 0, y-axis is 6. So 6 is equal to equivalent EMF. When three cells are in series, it is going to be 3A. So 6 is equal to 3, A is equal to 2. You will get the same. Okay. So having said this, shall I proceed? So this is what they expect. This is a 1 mark problem actually. Okay. Next. So read this. A wire of resistance 8R is bent in the form of a circle like this. What is the effective resistance between the ends A and B? Between the ends of a diameter 2AB. Okay. So I understand the question as between the ends of diameter AB. Okay. So I repeat the question. There is a wire of resistance 8R, which is bent in the form of a circle. Right. When you do that, at the ends of the diameter, there are 2 points taken. Our job is to find the equivalent resistance between those 2 points. It's a very simple problem. How to do this? Which one is in series? So I just give you an idea of visualizing it. Okay. Suppose there is a wire like this, right? This has resistance 8R. If I break this into 8 equal parts, each part is going to have how much resistance? R. See, without a second thought, you told me R, but how did you say? Why is it R? Because I broke it into 8 equal parts. What science is involved behind it? Think, you know the answer. Think about it. Can I give a different perspective to it? Can I say 8 resistors of resistance R are connected in series to get this kind of a wire of resistance 8R? Right. But the question is, when you cut it into equal parts, why are we getting them to be R? Anybody with the logic? A mathematical term that supports your answer. Sorry? But why are you dividing equally? Very good. So R is equal to rho into L divided by A. So when you break it into 8 equal parts, it is the same material. So resistivity is same. Area of cross section is same. So what is the only parameter on which it depends on? Length. Since the length is broken into 8 equal parts, it becomes 1/8 of the original value. Am I clear with this? Okay, listen to this. Next point is when I take and bend it in the form of, okay, ignore the shape. When I bend it in the form of a circle, there is a battery source connected here. The positive terminal of the battery is connected here, negative is connected here. Whenever they ask you to find the equivalent resistance, all that they need to mention is between which 2 points. If suppose the question says, I give you a question saying find the equivalent resistance of this network, it is meaningless. Because you should ask a question of between which 2 points. Meaning, one of the points is connected to the positive terminal of the battery, the other is connected to the negative. This is how the circuit actually looks like. This is how actually it looks like. Now, when this is there, since you are diametrically taking the points to be on either side, this is broken into 2 equal parts, upper part and lower part. So what will be the resistance of the upper part? It will be 4 ohm or 4R. Okay, because the question says 8R, and the bottom part will be 4R. Right. Our job is very simple now. Now, how is this 4R and this 4R? They are in parallel. Because this point, the potential difference between the upper part and the potential difference between the lower part is the same. That is one way of understanding. Or if you take the current here, according to Kirchhoff's law, what will happen? The current will get split as I1 and I2. In this case, I1 and I2 will be the same. So since the current is getting split, you can say that it is parallel. So 4R and 4R parallel, answer will be 2R. That's it. Are you able to visualize? Yeah. So make a note of. Yeah. Shall I proceed? Listen. The next question is, a 10-volt battery of negligible internal resistance is connected across a 200-volt battery and a resistance of 38 ohm as shown in the figure. Find the value of the current in the circuit. This is again a simple problem. Right? What will happen? This 10 volt will supply the current in the anti-clockwise direction. 200 volt will supply the current in the clockwise direction. So both the currents are opposing each other. So what will happen to the equivalent EMF in this case? So you should subtract the lower value from the higher one. So how will the circuit look like? 200 minus 10, it is going to be 190 volt, which is connected across a 38 ohm resistor. So 190 and 38, let's see. So we need to find the value of current. I is equal to V by R, 190 divided by 38. Is it 5 times? 38 fours is 40, so it is 5 times, right? So it is going to be 5 amp. Okay. Shall I proceed? So 5 amp here. See, show the variation of resistivity of copper as a function of temperature in graph. So what material is copper? It's a conductor, insulator, semiconductor. It's a conductor, no? So I'll give you time, open your textbooks and go to the page. Don't have a, okay, go to the page where resistance and resistivity varies with temperature. Then give it here. So page number 104. So look at page number 104. So tell me what graph will come. So read the question carefully. What is the relation between resistivity and variation of temperature? Rho is equal to rho naught into 1 plus alpha delta T. Remember that? Check your notes. Under the topic variation of resistance with temperature, I gave you this equation. Rho is equal to rho naught into 1 plus alpha into delta T. It was before Kirchhoff's law. Okay, check it. Then, okay, no problem. So which one, guys? The first one. So that's the answer. So what is the equation? Rho is equal to, you should remember this. Rho is equal to rho naught into 1 plus alpha into delta T. So based on this relation, you can say it is going to increase with temperature. So what is the last graph that you're able to see? Semiconductor. So there's one point I want you to have it in your mind. Whenever you talk about the value of alpha, right? Alpha is called as the temperature coefficient. So for conductors, the value of alpha is always positive, meaning, at least now make a note of it. Alpha for conductors is positive. This I've already given. So temperature coefficient of resistance or resistivity for a conductor is positive. Meaning of it. Meaning, as the temperature increases, resistance of a conductor will increase. Whereas for a semiconductor, it is negative. Meaning, if the temperature increases, resistivity decreases. That is why the third graph is in the downward direction. Is it getting registered? See, these kind of simple questions will be asked also. So be careful. Right? Did you all make a note of it? Alpha. So somebody asked you, what will you say? The temperature coefficient for a conductor is positive. Temperature coefficient of semiconductor is negative. It's the graph. Right. Next one. Two metallic wires of same material. See, whenever we see same material, what should come to your mind? I've already told you. Resistivity is same. They have the same length. L1 is equal to L2. But the cross-sectional area is in the ratio 1:2. So A1 by A2 is equal to 1/2. First, they are connected in series. Second, they are connected in parallel. Compare the drift velocities of the electrons in the two wires in both the cases, 1 and 2. Okay. So first, I want you all to find out what are the resistance of each. Do it. I gave you the equation already. R is equal to, I told you today, R is equal to rho into L by A. Find it out. So first find the resistance and tell me, that's enough. So what is the ratio of their resistances? Very simple, no? When A1 and A2 are in the ratio 1:2, R1 and R2 will be the ratio 2:1. That's all. No. So R1 by R2 is equal to rho into L1 by A1 divided by rho into L2 by A2. Or I'll write rho 1 and rho 2. So rho 1 and rho 2 are same. L1 and L2 are same. So this will come out to be A2 by A1. So this will be 2/1. Am I right? Okay. But what do I have to do with this? Had the question been about the currents, it was easy. But they're asking, compare the drift velocities of electrons in two wires in both the cases 1 and 2. So how do I relate this drift velocity to resistance? Or how can I relate? Okay, I'll give you another hint. How can I relate drift velocity to current? That is the second derivation that we saw in this chapter. First derivation was drift velocity. Second derivation was the relation between current and drift velocity. So when I write I is equal to NEA BD, so what will happen? So when I write the expression for BD, what will it be? It will be I divided by NE into A, right? Now tell me one thing. When I talk about series connection, so understand one thing, there is one wire like this and the other wire of exactly half the thickness. One is big and the other is small, or okay, whatever is the side you want to take. So when these two resistors are connected in series, what parameter remains constant? When two resistors are connected in series, current remains constant. So first I'll do for series connection. So when I talk about series, can I say I1 is equal to I2? So drift velocity in the first case divided by the drift velocity in the second case is equal to I1 by NEA or A1 by NEA2. So I1 and I2 will get cancelled, right? So what else will you get cancelled? NE and NE are gone. So what is going to be the answer? 2:1, right? So this is going to be the answer. So make a note of it. So is this logically right? Okay. Because you take the number of electrons per unit volume to be the same. Current is same, no? Let it be, but the number of electrons per unit volume is what you're taking. So in this question, what you're supposed to do is you need to take the number of electrons. What does small n stand for? Number density, what is it? I didn't take it as capital N. I'm saying the number of electrons that are present per the unit volume is a constant. So that is why it got cancelled. Okay. Let it be, ma'am. Let it be. Meaning, see, the volume is more, the number will be this. They'll be in the same ratio. What I'm trying to say is n is equal to n divided by a, no? N1 by A1. The ratio I kept it, sorry, n by V. I'm saying that the ratio is kept constant because nothing is mentioned here. Nothing is mentioned about the electrons, no? So you have to take that as the same parameter. What about parallel? So what about parallel? So it is the same logic again. Drift velocity in the first case divided by the drift velocity in the second case is equal to I1 by NEA1 into NEA2 divided by I2. Can I write it like this? I basically took this NEA2 through the numerator. That's it. So NE and NE will get cancelled. Here you are going to get I1 by I2 into A2 by A1. Now the question is, I have I1 and I2, but how is I1 and I2 and R1 and R2 related in the case of parallel? When I talk about parallel connection, if I take Ohm's law into consideration, V is equal to IR, can I say I is inversely proportional to R because for parallel connection, V is a constant, right? So since V is a constant, I is inversely proportional to R, meaning I1 by I2, I can write it as R2 by R1 into, here I'll write it as A2 by A1. What is R2 by R1? R1 by R2 is 2:1. So R2 by R1 is half. What is A2 by A1? 2 by 1. Answer will be 1:1. So ratio of drift velocity in the case of parallel connection will be 1:1. Done? Here with this? Okay. So I want you to derive this. Derive the expression for resistivity of a good conductor in terms of relaxation time of electrons. Okay, all that you need to do is go check the derivation. To check the derivation of Ohm's law. There I would have told you what is resistance and resistivity. Did I tell you? So what do we start with? We start with I is equal to NEA VD. So this will be equal to NEA into what is the value of VD? E into capital E divided by M into tau. Right. So E into E is going to be E square. But what can I write E as? V by L. Because we know that electric field is equal to what gradient? What is V? It's called potential gradient. So I is equal to N E square A by M into tau into V divided by L. So V is equal to ML divided by N E square A into tau. Am I right? Into I, sorry. Yeah. So this will be equal to M divided by N E square tau into L by A into I. So this is looking at which format? It is looking as V is equal to I into R, where this whole thing is R. And what about this bracket part? It's called as resistivity. So resistivity is equal to M divided by N E square tau. So they can ask you this kind of a question also. They'll not say derive Ohm's law, but it can be a part of the Ohm's law's derivation. According to this question, there is answer. Rho is equal to M divided by N E square tau. So what is the difference between resistivity and conductivity? What is the difference between resistivity and conductivity? Okay, both are properties accepted. Can you tell me in terms of mathematics? So both are reciprocals of each other. So conductivity is basically the reciprocal of resistivity. Similarly, what will be the reciprocal? What is the opposite of conductance? Sorry, what is the opposite of resistance? Yeah, conductance. So I hope you remember. If suppose in the same question they are asking you derive expression for resistance of a good conductor in terms of relaxation time, then you should write R is equal to ML divided by N E square A into tau. If they ask you only for resistivity, remove that L and A. Okay. Am I clear with this? Okay. Shall I proceed? M divided by N E square tau. That's what we wrote, no? Yeah. So using the mathematical expression for conductivity of a material, explain how it varies with temperature for semiconductors and good conductors. Just now I told you, no? For semiconductors, increase in temperature. No, they didn't ask in terms of temperature coefficient. So all that you need to say is when temperature increases, resistivity decreases for semiconductors, whereas for conductors, it will increase. Okay. So make a note. This is the expression. I need not tell you how you got this expression. Just now we derived it. Rho is equal to what? M divided by N E square tau. Okay. So if I write 1 by rho, it is called as conductivity. It is represented by the symbol sigma. So sigma will exactly be the reciprocal of it. This is the answer. N E square tau divided by M. Am I clear with that? It is N E square divided by, sorry, N E square tau divided by M. Now what are they asking is, with the help of the mathematical equation, explain what will happen in the case of semiconductors and good conductors. For what? For conductivity. Now tell me, with increase in temperature, okay, let's think of the logic. With increase in temperature, what will happen to the relaxation time? With increase in temperature, relaxation time will decrease. So if the relaxation time is decreasing, what will happen to the conductivity? That will also decrease. That's what happens with respect to good conductors, right? Whereas with respect to semiconductor, I cannot go in depth now. You can see the statement. With the increase in temperature, conductivity of a semiconductor will increase. Okay, it is due to inverse of V. Okay, it dominates the effect caused by the decrease in the value of X. So this is the reason they have given, but I'll tell you the logic is negative temperature coefficient. Okay, because the semiconductor completely has a different working principle. It does not work like a conductor. So why we use semiconductors is because it has two abilities. It can act as an insulator as well as a conductor. So depending on how you do something called as how you add impurities. I'll tell up. I'm not sure if you have heard of it. Did you learn about solid state? Chemistry, it is deleted, no? In the chapter also you'll have. So you'll have it in that chapter as well. There it would have been mentioned. Okay. So solve this. Prove that the current density of a metallic conductor is directly proportional to the drift velocity of electrons. Meaning, you need to derive the relation between current and drift velocity. So derive it. Where do we start with? For current and drift velocity, what do we start with? So I is equal to, you take Q by T into consideration. What is the value of Q? Capital N into E. So charge of each electron multiplied with the number of electrons. So how much is the time taken by the particle? It is going to be distance by speed. So it will be N into E divided by L into this VD will go to the numerator. What is the value of VD? I just now gave you. E into capital E divided by M into tau. So when you multiply both, it will be NE square divided by ML into tau multiplied with E. This is going to be the value of I. Oh, we want it in terms of NEAVD, right? Yeah, I have to keep it because that is a relation expected. No, they'll come from the beginning. I is equal to Q by T. So Q is N into E divided by L divided by VD. So it's actually simple. It is capital N into E into VD divided by L. All that we need to do is multiply and divide it with area. When you do this, area of cross section multiplied with length is going to give us volume. So capital N divided by volume is going to be small n into E into A into VD. What is this all about? It is current. But in this question, they didn't ask about current. They asked about current density. Bring the A to the left hand side. So I divided by A is equal to NEVD. So this is what is current density. So J is directly proportional to VD. That is what we need to do. Okay. Right. I hope you could understand. I'll tell you what you're supposed to. Okay. Shall I proceed? Diagram and all, it is there in your course. Cylinder. Experiment. I heard that you're asked to write your record work. No? Like, do you remember writing this experiment? இருக்கா இல்லையா? Meter bridge எழுதுனீங்களா? Meter bridge you wrote? Okay, 2 experiments are 1. See, first will be Ohm's law. Correct? Second will be 2 experiments based on meter bridge. One is series and parallel connection. I don't know whether you wrote 2 or 1. Both you wrote. Okay, that's a simple thing. Okay. Anyways, the one next to it is potentiometer. Just for information, I'll tell you what it is. If at all you get it in YY, you should not go blank. Okay. See, as the name suggests, no, potentio is coming from potential. Similarly, you have, what is the unit of potential difference? Volt. So you have two devices. One is called as voltmeter and the second is called as a potentiometer. Right. You can ask me what is the difference between them. They both seem to do the same job, no? That's what it's looking like. But a voltmeter will actually measure the potential difference. Potentiometer will help us to measure the EMF. Why do we use? To measure the EMF. We know what is the difference between them, right? Both sound to be similar, but they are not. When will you talk about potential difference? When the circuit is complete, when current is flowing through the circuit, right? Whereas when you talk about EMF, the circuit is open, right? So that is one point. You can ask me, why is this happening? See, when you talk about an ideal voltmeter, ideal means something that is imaginary, which is 100% perfect. It's not going to happen. When you talk about an ideal voltmeter, what is the resistance of? Because this data is needed for next chapter. That is why I'm asking. What is the resistance of an ideal voltmeter? Think and tell them. It is infinite. Okay. What about an ammeter? It is 0. This is okay, but can you tell me what is the logic for behind it? Since you have learned current electricity, no? I want to know why is it so? I'm saying, why should an ideal voltmeter have infinite resistance? Since you learn current electricity, I want you to think and tell me. See, if I'm your Viva instructor, Viva external role, I'll ask this question. I'll ask questions like, you will draw a circuit for Ohm's law, no? I'll ask you what will happen if you interchange the resistor and battery. I want you to think in those terms. I'm not concerned about outputs. Okay, if that is the case, let's say, why should an ideal voltmeter have infinite resistance? I can give you the hint. It is so whenever you say a device has infinite resistance, what is the amount of current that is allowing through it? When something has infinite resistance, what is the amount of current that is allowed through the device? 0. Obviously nothing. See, resistance is another. My hand is there. Okay, let's say there's your hand, there's my hand. I'm trying to push you and you're trying to resist me. If both is happening, if you're offering me infinite resistance, will I be able to move my hand? Right. Same as the case with current. My hand is current. This is the resistance that you're offering me. Similarly, if it is 0, what will happen? I can easily push it across. Means more amount of current is going to flow through the circuit. So tell me one thing from your 10th standard basics, how will you connect a voltmeter across a circuit or across a resistor? Why? You know the answers, but you don't want to think. Parallel. I told you one thing. Parallel and word pathali, there is potential difference is same. What are you measuring? Potential difference across a device. So anga irukra value inga varnuna, you should connect only in parallel. Correct? That's the simplest logic. Right? So when you do this, what will happen is, if suppose you have a resistor here and you connect a voltmeter here, right? When you connect a voltmeter, if suppose you are saying I is the amount of current that is flowing, listen to this carefully. If I say the amount of current that is flowing before this network of parallel connection is I. According to Kirchhoff's law, what should happen? Here it should be I1, here it should be I minus I1. Makes sense? But if this is offering infinite resistance, what will be the value of I minus I1? You told that it is going to be 0. When it is 0, what is that you are ensuring? that all the current is flowing through the resistor. If that is the case, then the potential difference across the resistor V will be equal to IR, and you're ideally saying that is the value you're measuring here, but it will not be the same. It will not be the same. There is nothing like ideal voltmeter. The general resistance of an voltmeter will be somewhere around 5,000 to 6,000 ohm. It is happening because of the coil that is wound inside it. Next chapter, when I teach you, you'll understand why it is happening. Okay. So that is why you will not be able to measure the EMF because it is not actually happening in an ideal situation. So what do you mean by EMF? I'll show you. Wait. I don't know if you guys can see it. Anybody knows what it is? What are the values you are able to see? Left club, different terms that you know. Mean another. A is current. Ohm. So this is a meter which can measure multiple values. Another multimeter. So it can behave as a voltmeter, ammeter, it can measure the resistance value, right? That is an ohm meter. Okay. So that's why it's called as a multimeter. And these are the two electrodes that you're going to use. Okay. Now, if I keep it like this, I'm interested to, I told you, I want you to understand what EMF is. Unfortunately, I can't show you the value. I have a battery here. Okay. What is the value written on top of it? It is a 9-volt battery. Okay. So this is what I got from shop and came. So when I keep the electrodes across the positive and negative terminal, what should my multimeter show? Or what should my voltmeter show? 9-volt cartnola. This is negative and this is positive. How much is the value coming to? 9 point. So it's coming to 9.39 actually. Okay, that is because it is new. And one more thing is the value that is written here is having slight error. It is having a positive error. It is more than this value. But let's say if I use this for 10 days and I ask you to measure the value, it will not show anywhere around 9 point something. It will show something less. This I told you in the beginning itself, you remember. So what you are actually measuring here is not the EMF. It is going to be the potential difference because you're drawing some current out of it. This device itself is working in such a way that it is drawing some current out of this battery and it is using digital validation. So it needs to draw some current and it needs to do some calculations inside it. That is why you're able to see this value. Same work is done by voltmeter. An ideal voltmeter will not have infinite resistance. It will have somewhere around 5,000 to 6,000. That is why you need another device called as a potentiometer for you to measure the EMF. Okay, actually, when you do that experiment, right, they'll give you two big cells. The electrochemical cells will be given to you in the lab. Okay, for which you'll be asked to compare the EMFs, not measure the EMF. You'll be asked to compare. If at all you have a chance, go and see. You have that observation book which they gave you in the school. Or observe a or legal size loan. They didn't give her. Then how, where are you writing from? Okay. So on the book, I don't know if that experiment is there. I don't know what book they uploaded, but there is a book. You are able to understand why potentiometer is needed. This is for your knowledge. I'll show you. If time permits, I have all those devices. I'll show you. One day I'll spend time for lab. Okay. But anyways, this is not needed because if you see potentiometer, no, look at the question itself. Calculate unknown EMF of this. So that's how it works. But I hope I could make some sense in making you understand what is the difference, right? So this is the formula actually. This E1 by E2 by E1 is equal to L2 by L1 is called as the comparison of EMFs. So this is the formula based on which you'll do the practical. But anyways, don't worry about it. Okay, what is the time? So 5, no. I'll do one thing. So tomorrow I'll continue with this. I'll solve some more problems, right? And this weekend you will have a worksheet based on this chapter. So work on that. And on Monday, you have any doubts, I'll clear it for the first 20 minutes, post which I will be starting magnetic effects of current. It is somewhat similar to what you have learned in your 10th grade, except the fact that we'll be seeing a lot of mathematical formulae related. You would have learned right-hand thumb rule and everything, no? So I'll teach you a little bit of integration and then start with it. Is that point clear? So any other questions? Tomorrow mostly, yeah. Actually, I thought I'll be traveling because I told you, no, there'll be a test, but I might not travel. I don't think I'm traveling. So it'll be normal class. Okay. So leaving the next week, right? The week next to it, you will have a test. That is, after 2 weeks, you'll have a test in this chapter for 40 marks. Start preparing for now onwards. Okay. It is the exact pattern as what was given last year. That MCQs, assertion, reason based question, case based questions, and subject. So start preparing. That's it. I'll see you guys tomorrow.